Let's say you are driving a car and then you see a policeman ahead. You would want to apply the brakes of the car in order to avoid hitting the policeman. The distance while applying this brake is called the distance during deceleration or the braking distance. During the reaction time, the distance your car moved is referred to as the thinking distance. An automobile driver moving at 30 meters per second suddenly saw a policeman standing 70 meters ahead. If the reaction time is 0.5 seconds and the maximum deceleration is 8 meters per second squared, can he avoid hitting the policeman without steering to one side? The time of reaction of the driver is 0.5. Then he applied the brake. For the driver not to hit the policeman, the distance from the point at which he sees the driver must not be up to it must not be up to 70 meters. That is, the sum of the thinking distance and the braking distance must not be up to 70 meters. If it is more than 70 meters, then it will hit the policeman. The thinking distance is the distance during the reaction period. That is the time where the driver sees the policeman. And then the braking distance is the distance during the deceleration, during the application of the brakes. Okay, now let's find the thinking distance. That is the distance that is required during the reaction period, that is before the application of the brake. So distance before the application of the brake, let's say the thinking distance, which is the same thing as the distance covered before applying the brake. Okay, the distance before the application of the brake, let's say that is d1. So that the d1 is equal to velocity times time. The time that is spent during this thinking is the reaction time. Of course, the thinking distance is the distance during the process of reaction. So after he sees the policeman, then that is the beginning of the thinking distance. Okay, then upon the application of brake, the thinking distance ends, and then we also find the distance during the application of the brake, which is the distance during deceleration. So the velocity at which it moves is 30 meters per second multiplied by the reaction time, which is 0.5, and that's half, so which is 15 meters. And then we need to find the braking distance. The braking distance is the distance during deceleration, that is during the application of the brake. How long did the car move? All right, that's the distance we want to look for. Now let's say that is d2, which is the braking distance, or the distance during deceleration. Okay, let's say that is d2. Now to find the distance during the deceleration, we may use this formula, which is v squared equals to u squared plus 2gs. Notice that the final velocity v will be equal to 0, because the car would decelerate until it comes to rest. So the final velocity will be 0, so that we can say that using v squared equals to u squared plus 2as. So the v squared is 0, and then the initial velocity squared, of course, that is 30 squared plus 2as. The acceleration in this case is negative because the car is decelerating, so we'll have minus 8 meters per second square. Then our s is d2. Okay, so that 0 is equal to 900 minus 16d2, so that by taking 16d2 to the other side of the equation, we'll have 16d2 equals to 900, so that d2, which is the braking distance, is equals to 900 divided by 16. 900 divided by 16 is equal to 56.25. Let's say the driver is at point A when he sees the policeman. Then from point A he begins to react, and it took him 0.5 seconds to react. Let's say the distance is spent during this period of reaction is 15 meters. Now, then from point B, he applied the brake because he had already reacted. He applied the brakes. Then, upon the application of brakes, he spent, let's say this is point C, then he also spent 56.25 meters. Don't forget that from this point, he had seen the policeman 70 meters ahead. In order for him to avoid hitting the policeman, the summation of the distance from point A to C must not be greater than 70. So we'll have 15 meters plus 56.25 meters, which is equal to 0.25 meters. Therefore, he cannot avoid hitting the policeman. He will hit the policeman. Let's say this is the point A, and then this is the point B, and then this is the point C. The policeman will be somewhere here, and the difference between the distance of the policeman and the car will be, it will just be 1.25. So he can't avoid hitting the policeman without steering to one side. Okay, now let's solve the other problem. A car is moving with a velocity of 20 meters per second. The driver sees a stationary truck ahead at a distance of 100 meters, and after some reaction time, the brakes are applied, producing a retardation of 4 meters per second. What is the maximum reaction time to avoid collision? So let's say this is point A. When the car gets to point A, then he sees a stationary truck ahead at a distance of 100 meters. So he needs time t to react. Okay, so after that, then he applied the brakes at this point. So during the application of the brake, it will also move at a particular distance. So don't forget that upon the application of the brake, then the car begins to decelerate. So the braking distance is the same thing as the distance during deceleration. So when the brakes are applied, the retardation is minus 4 meters per second. Okay, so we will need to find the distance. Let's say the distance here is d1, and then we would find the distance here as d2. All right, the sum of this distance must not be greater than 100. If it is greater than 100, then it will collide with the truck. If it is less than or equal to the truck, then it can avoid collision. So let's find the distance d1. To find d1, we can say d1 is velocity times time, which is 20 multiplied by the reaction time, and of course that is 220t. So we can find t2, of course d1, d is equals to velocity multiplied by time from the formula, which is velocity equals to distance upon time. So I made d the subject of the formula. All right, so to find d2 will also be velocity upon the time, but in this case we don't have velocity, we only have acceleration. So we can make use of the equations of motion to find d2. So we can actually use v squared equal to u squared plus 2as. Notice that in this period v will be equal to 0. All right, because the object would decelerate to rest. All right, so v squared is 0, then u squared, u is initial velocity, which is 20 squared, then plus 2. The acceleration in this case is negative, is a retardation, so the s is d2. So this is 0 equal to 400 minus 8d squared, which if I take this to the other side of the equation, I'll have 8d squared no, 8d2 equal to 400. So that d2 is equal to 400 divided by 8. So that's 50 meters. So the distance from this point to this point is actually 20t, and then the distance from this point to this point is 50 meters. So this distance, the sum of this distance must not be greater than 100. If it's not greater than 100, then the collision will be avoided. Then it means that 20t plus 50t must be less than or equal to 100. So let's consider the equal to, that is 20t plus 50 is equal to 100. We can't consider the less than sign because we are not solving inequality problems. So we can say that 20t is equal to 100 minus 50, so that 20t is equal to 50. As a result, t is equal to 50 upon 20, so that's 5 upon 2, and 5 upon 2 is the same thing as 2.5 seconds. So the reaction time is 2.5 seconds. Now let's solve the next practice problem. If a car drives with a speed of 80 km per hour and suddenly the driver reacts and pushes on the brakes with the reaction time of 0.6 seconds and the acceleration is minus 6.2 meter per second square during the braking, calculate the braking distance and the shutdown distance. Alright, this is the speed of the car of the driver. So let's say the driver is at point A, and then it moves, the distance at which the velocity at which it moves is 80 kilometer per hour. 80 kilometer per hour. So we can convert this to meter per seconds, so that it becomes 80 exponential 3 the meter upon 3600 second. Alright, so which will become 22.22 meter per second. Now then he moves with this velocity, and then the driver suddenly reacts and pushes his brakes. Now in order to find the braking distance, notice that the braking distance is the distance during deceleration, or the distance that the car will move during the process of application of brake. That is, while you are applying the brakes, how long will the car travel? That's the braking distance. And then the shutdown distance is the sum of the braking distance and the thinking distance. Notice that the thinking distance is the distance while you are reacting. That is, after seeing the hazard ahead, or after seeing the policeman ahead, the distance from the point at which you have seen the policeman to the point where you apply the brake, that is the reaction time. So the distance from that point is the thinking distance. Notice that the thinking distance is before the application of the brake, and then braking distance starts from the application of the brake. Now let's find the braking distance. The braking distance during the application of brake, notice that the final velocity is 0, and then the acceleration is negative because the car will be decelerating at the rate of 6 meter per second squared. Okay, and then the initial velocity u, that will be 22.22 meter per second. Alright, so we can find the braking distance, since v squared equals to u squared, then plus 2as. Okay, where s is the braking distance, then v squared, that's 0, then u squared, that's 22.2 squared. Okay, 22.2 squared. Okay, let's have it, 22.2 squared plus 2a in this case is negative 6.2, then the s. All right, so 22.2 squared is 493.827, then minus that is 2 times 6.2, which is equal to 12.4. 12.4s equal to 0. All right, so if I transfer this to the other side of the equation so that I will obtain positive, I will have 12.4s equal to 493.827. So divide both sides by 12.4. If you divide both sides by 12.4, the breaking distance s will be equal to 493.827 divided by 12.4, which is equal to 39.824 meters. So 39.824 is the distance during the application of brake. That is, while applying the brakes, the car moved at a distance of 39.824 meters. Now, in order to find the shutdown distance, which is the sum of the braking distance s and the thinking distance, let's say the thinking distance is h and the thinking distance is the distance during the reaction period. That is why you see the policeman ahead. How long did you move before you apply the brake? So, and of course, the distance is velocity multiplied by the time, where the time is the reaction time. So the velocity in this case is 22.2 multiplied by the reaction time, which is 0.6. And of course, that will be 22.22 multiplied by 0.6. That's 13.33. All right, so the the thinking distance is always very small due to the reaction time. The reaction time is always small as well. So also the thinking distance, because it requires a very little amount of time to react before you press the brake so as to avoid hitting the person ahead or colliding with the object ahead. So the shutdown distance is therefore 39, that's 39.824 plus 13.33, which is equal to, that's 39.824, which is equal to 53.156 meters. So this is the shutdown distance, is the distance at which the objects, at which the car is required to move throughout the whole journey, and this distance will determine if the car will collide with the object ahead or not. And it is the sum of the braking distance and the thinking distance. Thanks for watching. Share with your friends. Make sure you watch the next video.